So I'm going to briefly go a bit of an introduction to Russell IPM for those who don't know the company. Talk a bit about thrips and whitefly, why we need extra methods of control. Then the whitefly traps, thrips traps, and conclusion. So Russell IPM is a manufacturer of semi-chemical monitoring and control products. We actually market in 45 different countries, both for agriculture and public health. We get involved in monitoring rats as well. It's a rather innovation-led company. We've Shakir, who's our managing director, is a bright spark with 101 ideas every day, so keeps us on our toes. And we've got quite a lot of facilities. We're based in North Wales, Deeside area. So we can do pheromone identification. Obviously, we use it for quality control. Unique slow release formulations. We've got chemists there. 3D printing facility. We produce traps. And increasingly we're looking at biopesticides as well. So, back to my first love, thrips and whiteflies. Both worldwide pests, and the main problem we've got is that they've developed resistance to almost all of pesticides, the chemical insecticides we've got available to control them. So since they arrived in the UK, really we've been developing biological systems. And when you're using biocontrol, very often what breaks down is people use a chemical that kills the biocontrol and you get a resurgence. And then you get residues in the crop, you can't sell your crops. So natural enemies work very well most times, but there are times when they break down. In tomatoes we're growing at lower temperatures, we get pest invasions, we have to spray repeatedly for disease control, and that can knock away the predators. So we have been working on a solution really to combine the use of traps with biological pest control to get us a more robust system, sort of belt and braces approach. So the biocontrol mainly feeds on the larvae stage, and you can add the traps to catch the adults. But we are moving forward. Biocontrol is the main control, so we've got to be compatible. Our traps have got to be compatible with the biocontrol. So we had a 2-year project with Keele University. It was a knowledge transfer partnership project, and I was the associate. So it was Keele University, William Kirk, Gordon Hamilton, and with Russell IPM. So we're looking at, can we improve the attraction of the traps without affecting the attraction of natural enemies? And then looking at the pest control effects. So we're looking at colour, pattern and scents. So starting with the whiteflies, trap colour, I think the first yellow sticky trap was back in 1914, and they've changed very little since then. And we know that whiteflies, I don't know if it's got a pointer. Oh no, it's gone black. That's not a pointer. Yeah, so the whiteflies are attracted to reflection at about 550 nanometers. And here's the typical colours of yellow sticky traps, and you see they're most attracted to yellow. But it turns out it's rather more complicated than that. It's not only the wavelength of maximum reflection, it's the amount of reflection and how see-through the traps are. And if you've got slightly different tones to your yellow, you get quite a big effect on the amount of non-target species. So if we move slightly to a duller yellow, we were still getting, if you see the chart on the right, on the left, of whiteflies, we were still getting similar numbers of whitefly, slightly more of the trend, but we were getting fewer of the non-target species, like fewer bumblebees, honeybees, parasitic wasps, anthocorids, and fewer thrips. I know thrips is also another pest. If you go to a much brighter trap, so more reflectance, rather similar colour, but slightly brighter yellow, you're getting much wider range of natural enemies. So we were trying to select a trap that has maximum whitefly without catching the natural enemies. So when we changed the colour of our traps, we improved it, we actually almost doubled the trap catch of whiteflies for our roller traps. And we've developed two types. One is the OptiRoll there is more of a high density film. So it's more for use outside and in tropical countries, doesn't break down. It's harder to pull flat, so it's whatever growers want really. But the ActiRoll, it's not significantly different in the trap catch there, but the trend is it catches slightly more than the OptiRoll. But it's a lower density film, it stretches out nice and flat, but probably tears more easily. So it's two different films really for most glasshouse growers would prefer ActiRoll. Two different films for two different situations, but both very effective. And you'll see from the picture, this is from a glasshouse where they're using bumblebee pollination, and you very occasionally get a bumblebee that's just sort of stumble into it, but you're not getting a catch of many bees in there. So then we looked at trap pattern, and we did an extraordinary number of trials looking at the percentage of black pattern, the distance between lines, circles versus lines, all sorts of things, and I'm not going to present all the results. We had some interesting trends. If you got too much black, it actually reduces the trap catch. But if you add a certain patterns, you got a significant increase in the trap catch. And if you look at the top picture there, you'll see the whiteflies are lining up along the pattern there. And the main response is not on the black side, because it's printed on one side of the trap, but it's on the reverse, on the non-printed side. Oh, thank you so much. Which one did I press? I think so. Oh yes, there we go. It's just not showing much. Thank you, yeah. Yeah, so you can see here they're lining up along the back of the pattern. But here was the problem for me. I did all the trials on one set of traps, and then we improved the trap colour to a trap colour that was less see-through, and I didn't get the same response of pattern because, of course, it's only for where they're showing through. So it's not for all pattern traps. It's like ongoing, continuous improvement of these traps. But on certain traps, we've got a very big response to pattern, but it might be more to do with changing the colour of the pattern rather than the actual pattern itself. And some of the patterns, as you can see here, attract non-target species. So this round circle attracts bumblebees because they think it's the entrance to their hive. So you always get bumblebees around the edge. So we're learning a lot about pattern, and we found some patterns that increase the trap catch, but no significant effect on natural enemies. It's only on certain film types. So again, it's a choice, really. So taking it forward to quite large-scale field trials, again, this is showing, I know they're not significantly different, but the trend was always the same. You know, too much pattern, you've got double line, so that's too much pattern there. But it's still better than plain. But when we just had a single line in the middle, that was the best trap catch. And we got the same trend against Bemisia, Triluriodes, Spain, UK, tomatoes, strawberries. But it's only effective on the old trap colour. So taking all these developments, well, we don't really care necessarily just what's on the trap. It's what's the effect on the crop that we're looking for. And here's just share with you a couple of examples. A spring trial here. This is with the demi-roll. It's 15 centimetre rolls in a strawberry glasshouse crop, with and without traps, in an IPM system. 7 replicate plots, again, just 9 metre sections of 2 rows, and then assessed whiteflies per leaf. And the crop ran from January to April. And you'll see at the start, when we put the traps out, no significant difference between the whitefly numbers. But by February, it was 84% fewer whiteflies where we'd got the traps compared to no traps. As it went on, by April, you're getting quite a lot of whiteflies, and you've got less of an effect. Basically, because the trap's becoming so contaminated with whiteflies, you didn't see the same effect. So they're most effective at the start of the crop when you've got fewer whiteflies. But you can see it's still a very good help. Now, traps aren't enough on their own. You can see here we're getting up to 5 whiteflies, more than 5 whiteflies per leaf. It's more than you want to see. So it's a combined programme. You know, it helps with whatever control method you're using. But it's very consistent reduction in whitefly numbers. And then this summer trial is still running. I'm doing the last assessment on Monday. We had no traps, the old standard, and the 2 new trap types, 7 replicate blocks again, counted whiteflies on the leaves and on the trap. So 6 weeks after the start of the trial, again, this was the standard roll, previous roll, and you can see again the new trap colours have more than doubled the number of whiteflies per trap area. And all 3 significantly, well, the new rolls significantly brought the whitefly numbers. Quite a lot of variation in the block. Whitefly, you can have 100 on one leaf and none on the next. It's very patchy distribution. But it'd be interesting on Monday how that's changed. So this is after 6 weeks. Again, you're getting a very big reduction in whitefly numbers just with adding traps, and no interruption in the IPM bumblebees or anything like that. Okay, so moving on to thrips. Again, trap colours. So our main pest target species is western flower thrips. And again, western flower thrips, we know from some early papers by Brodsgard, is very attracted to a very specific blue colour. And the Russell IPM blue colour is very effective. If it's too light, you don't get many, and it's not nearly as good as white or yellow for thrips. So the wavelength's not only important, but the percent reflectance of that colour is also important. In contrast to thrips, to whiteflies, thrips like more shiny traps, so a high reflectance. So the first thing we wanted to do is add the thrips aggregation pheromone to the traps. So again, we want to increase the thrips trap catch without affecting natural enemies. So the aggregation pheromone is produced by the male, and it attracts both males and females to the traps. And it's not like moth traps where they don't come from miles and just to the pheromone. Thrips land in response to colour. So they sense the pheromone, then they land in response to colour. So they need the colour, the attractive colour of the trap. But by adding the pheromone, you double the trap catch. So you must have the attractive colour. And lures are available from several companies. Syngenta are the main producer. And we wanted to incorporate it into the roller traps so that the grower don't have to add another lure. So it's all fully incorporated. So that's what we've done. I'll come back to the full results in the field. But we've also added a white pattern onto the blue traps and found that it increases the trap catch by about 25%. So it's not a huge amount. Again, those two are not statistically significant difference, but the trend's always the same. I've got some trials where they are. I've just shown this because I've got the main competitor trap in. So again, they're twice as effective as the main competitor trap. And we've confirmed it again in different countries and different crops. And in fact, I've just been looking at some data yesterday where the pattern's not only increasing the trap catch of western flower thrips, but increasing the trap catch of Thrips major. So it's a double benefit. It's not only western flower. So the pheromone increases western flower thrips, and the pattern increases a range of Thrips species. So what's the effect in the crop? So again, this is this year's trials: plain roll, patterned roll, pheromone roll, and put a main competitor trap in for good measure. Randomised block design, and I also assess the thrips on the traps and on the plant, but also aureus, because that's one of the main predators used for thrips control. I mean, in the UK mainly we use predatory mites because it's a bit cool for aureus, but certainly on the continent aureus would be the main beneficial predator. So there's rather a lot of information on this slide. So on the left-hand chart there you've got thrips on traps, and I think the main thing there is that the pattern trap here, the pheromone trap, both significantly better than the main competitor trap, twice as good in fact. And again in the flowers you can see it. This is no traps here, and these pheromone traps and pattern traps have more or less halved the number of thrips in flowers. And we've tested them now for many seasons and in different crops with different growers, and I'm always getting a more than 50% reduction in thrips numbers per plant, and sometimes as much as 80%. So they're really consistent, and they can be integrated with biological or chemical or various methods. When we did an assessment of what does it mean, the return to growers, including the cost of putting the traps out, a grower, we got a return of over £2,000 per hectare because there was an increase in class 1 fruit, less damage. So the damage, reduced damage equates almost directly to the amount of thrips per flower. So if you get 50% reduction in thrips, you also get 50% reduction in damage. And there was no statistical significant difference in the aureus population in flowers with or without the traps, so it integrated well with the aureus. So, how to use them? Apply them from first flowering. It's not a quick fix, it just catches them gradually over time. They can be there out for many months without any problem. Put them at flower height, replace early June, so you might put them in April, beginning of the season, depends on your cropping system. Replace in June, they'll last to the end of the season. Combine with cucumeris, you need the predators as well as the traps to have complete control, but those growers have adopted the system, have had complete control now for 3 seasons. You might get a tiny bit of damage right at the end of the season, but generally they've kept it below that economic damage threshold right through the season. It's been really successful. We've looking at increasing, we've got a chemist who's encapsulating the pheromone to get an increased longevity of the pheromone from the trap. Because at the moment we just got an emulsion into the glue of the trap, and it works. What the data I showed you is still got an effect 6 weeks later, but we want it to last even longer. And then if there's a demand for it, we've now got a system where we can, we're still in development, but we now have a method of making them into biodegradable traps. Of course, the dilemma is you don't want them to biodegrade too quickly because these are quite crop, they have to be out in the crop for. Some people are leaving them up for 6 months. Oh yes. Oh, so go back to that. I think they're an absolute pain to put up. There's no way around it. But growers are, as ever, very inventive, and there are now methods. In glasshouse crops, there's some clips that you can clip them to the vertical support wires, like in tomatoes, and now they'll go up with that. As the tomatoes grow, you can move them up. We're developing some clips so that you can attach them to the polytunnel legs very easily. In some Dutch greenhouses, chrysanthemums, it's totally automated now, putting them out. So there are methods coming on, so it's easier to, I mean, you don't really want to be putting everything up by hand into the future. I think that's an area that's going to improve with development. But that's so frustrating. You buy all your traps and then spend a lot of time putting them out, and they're on the ground 2 months later. It's not what we want to see. So in summary, yeah, the patent pheromone traps, they've reduced adult thrips per flower at least by over 50%, increased class 1, increased returns to growers. We've had no interruption with bumblebee pollination or the predators. We've reduced the number of insecticide treatments. So the combined use of predatory mites and traps has prevented major damage. So it has been quite a successful story. I think that's it. Thank you very much. So Innovate UK, thanks to Innovate UK for funding the project, and Keele University. NRI have been kindly measuring the pheromone release rates in tunnels, and especially to growers. So Flavour Fresh, Haygrove, Busby's, two lots of Busby's, Simon Clark have all been really fantastic, letting me going in and doing trials in their farms. So yeah, if you want to speak to me, that's my email address if you want further information. And the traps are being sold through various distributors in the UK, of which I have to mention Agriland, because they have some of the traps on the stand next door, so you can have a look at them. Thank you very much.